We were doing arithmetic progressions, and we will continue with arithmetic progressions. Let's look at this one. So we have basically sums based on an formula. Okay, sums based on an formula. So the 17th term of an AP exceeds its 10th term by 7. Find the common difference. So we have to basically find out here the common difference. Let's take this on a different. So the 17th term of an AP exceeds its 10th term by 7. Find the common difference. So obviously we are not aware of the first term, neither the common difference. So let's assume here, let the first term of the AP be A and let D be the common difference. Okay, so the 17th term, what will be the 17th term? We know that an is equal to a plus n minus 1 into d. So a17 will be equal to a plus 17 minus 1 into d. So a17 will be equal to a plus 16d. So this becomes your first. We cannot say that this is an equation because obviously three terms are not known here. Okay, so a plus 16d. Now let's talk about the 10th term. Similarly we can say that the 10th term here will be equal to a plus 9d. So this will be the 10th term. Just as we have the 17th term here, this will be the 10th term. 17th term of an AP exceeds the term by 7. So obviously this will be your first one and this will be your second one. So here we have A17, 17th term of the AP exceeds the 10th term. 17th term of the AP exceeds the 10th term by 7. Okay, so here we have 7. So if we happen to sort this out, A17 will be A plus 16D minus A plus 9D. That gives you how much? 7. So A plus 16D minus A minus 9D is equal to 7. This gets cancelled. 16D minus 9D, that is 7D is equal to 7. Okay, so therefore D will be equal to 7 by 7. That's equal to 1. Okay, so this is the common difference. So find the common difference. Therefore the common difference for this AP is 1. Okay, all right, let's go ahead with the next problem. So if we look into this, the 17th term here is, so if we subtract this, obviously the common difference would be 1. Let's take up this problem. Determine the AP whose third term is 16 and whose 7th term exceeds the 5th term by 12. So whenever we have a situation like this, wherein we have to find out the terms, or wherein we have to find out the second or the common difference and all, so we will have to basically chalk it out as to how to find out. Okay, now let's say again here in this one, the first term is not given and neither the common difference is given. So how do we do this? Determine the AP whose third term is 16 and whose 7th term. So let's again assume, let A be the first term and let D be the common difference. Let A be the first term and D be the common difference. Okay, determine the OP whose third term is 16. So here we have T3, or rather so if we apply the formula, AN is equal to A plus n minus 1 into D. A plus n minus 1 into D. So here how do we find out the third term? Determine the AP's third term. So A3 is equal to A plus 3 minus 1 into D. That gives you how much? A plus 2D. So A3 is equal to A plus 2D. So that's basically a plus 2d. This becomes your equation number 1. Okay. Determine the APs whose third term is 16 and the seventh term exceeds the fifth term. So here we have the seventh term exceeding the fifth term by 12. Seventh term exceeding the fifth term by 12. So let's look at this. So what will be the seventh term? A7 will be equal to obviously a plus 6d, just as we have here a3. Okay. And what will be the a fifth term? A plus 4d. If I happen to subtract this, this will be a7 minus a5 is equal to, this minus and minus gets cancelled, 6 minus 4d, that is 2d. What is the value of a7 minus a5? That is 12. 12 is equal to 2d. So therefore d is equal to 12 by 2, that is 6. D will be equal to 6. So the common difference here is 6. Now since we have two equations and we have two unknowns, out of which we have already found one. So here d is equal to 6. Now substituting, so here we have whose third term is 16. So third term is 16. We know that the third term is 16. So in this case, the third term a3 is basically 16. So in place of a3 we put as 16. A plus 2d. 2d means 2 into 6. So that will be 16 is equal to a plus 12. So a here will be 16 minus 12, that is 4. So the value of a comes out to be 4. So determine the AP. So what is the AP here? The first term is 4. What will be the second term? Obviously a plus d, that is 4 plus 6, that is 10. The third term is 10 plus 6, that is 16. The fourth term will be 16 plus 6, that is 22, and so on and so forth. So this basically becomes the AP. This basically becomes the arithmetic progression. Okay. All right. So let's move ahead. So if we look into this, this will be A4. So the required AP will be 4, 10, 16, 22. The same as we got as an answer. Okay. Which of the APs will be 132 more than its 54th term? So here we have an AP which is given as 3, 15, 27, 39. Okay. So we have to basically look at this. So here the AP is given to you. Obviously, by just looking at the AP, we can say that the first term here is 3. And what will be the common difference? It will be 15 minus 3. That's how much? 12. So A here is 3. And what is the common difference? 15 minus 3, that is 12. Okay. Here it is asked which term of the AP will be 132 more than its 54th term. So what about the 54th term? We know that AN is equal to A plus N minus 1 into D. So AN here A54 will be equal to A plus 54 minus 1 into D. So that will be A plus 53D. So this is A54. This is basically A54 is equal to A plus 53D. Now, the term that we are looking for is 132 more than this. The term that we are looking for is 132 more than this. So therefore, the required term will be how much? This will be A54 plus 132. So that's going to be A plus 53D plus 132. Now let's put the values here. The value of A here is 3 plus 53 into 12 plus 132. So that's going to be 135 plus 53 into 12. So let's quickly do this maths here. 3 2s are 6, 5 2s are 10, 3 1s are 3, 5 1s are 5, 6, 3 and 6. So this will be 6, 3, 6. So what's the value here? 6 plus 5, 11, 3 plus 1, 4, 4 plus 3, 7, 6 plus 1, 7. So the value here is, so for this term, so required term, let's say AN. The required term AN is equal to 770. So now you have to find out which term. So you have to find out the value of N. We know what is AN. We have to find out the value of N. So we know that AN is equal to A plus N minus 1 into D. So in the place of AN, in place of AN, we can write A plus N minus 1 into D is equal to 771. Okay, so A is how much? Again, we know A is 3. N is not known to us in this case. In place of D, we know D is 12, is equal to 771. So first of all, what we have done is found out the value of AN, and accordingly we are doing this. So N minus 1 into 12, that is going to be 771 minus 3. So 771 minus 3, that's going to give you how much? 8. So this will be 668. N minus 1 into 12. So N minus 1 will be equal to 668 by 12. So 12 5s are 60. I am doing some mistake here. Which of the terms will be 132 more? So then the 54th term. So 53 into D. 53 into D. Here we have 50. D is 12. Okay. A is 3. Correct. Okay. And the required term is A54. So A plus 53D plus 132. So this will be 3 plus 53 into 12 plus 132. So 132 plus 3, that gives you 135. 3 2s are 6, 5 2s are 10, 3 1s are 3, 5 1s are 5, 6 3, 636, 636, 6 plus 5 11, 3 plus 1 4, 4 plus 3 7, 6 plus 1 7. That comes out to be correct. Okay. Oh, 668. That's the mistake that I made. I am so sorry. That will be 68, 768. I am so sorry about this. Okay. Okay. So here we have 768. So N minus 1. N minus 1 will be equal to 768 by 12. So 12 6 are 72. 12 4s are 48. So N minus 1 is equal to 64. So therefore N will have a value of 64 plus 1. So N is equal to 65. N is equal to 65. So which term of the AP? So therefore we can say therefore the 65th term of the AP. 65th term of the AP. That would be the answer. Okay. All right. Oh, let's move on to the next, or rather let's move on to the solution here. Let's move on to the solution here. So that's going to be A54. So this is 636. So this will be 64, 65. 65th term of the AP will be 132 more than the 54th term. How many digits are divisible by 7? Let's quickly look at this. How many 3-digit numbers? So we will have to first find out the first 3-digit number, and what is the first 3-digit number that is divisible by 7. So obviously the 3-digit numbers, the first 3-digit number here we have the first 3-digit number. The first 3-digit number is how much? 100. The first 3-digit number is 100. So what is the first number that is divisible after 100? So 101, let's check for this. Is it divisible by 7? 7 1s are 7, leaves you with a 3. 31 is not divisible by 7. 102 obviously will not divisible by 7. 103 no. 104 no. 105, 7 1s are 7, leaves you with a 3. 7 5s are 35. So this is the first 3-digit number which is divisible by 7. Now let's look at 1000, which is the which is the first 4-digit number. Before 1000 we have 999. So 7 1s are 7, leaves you with a 2. 7 4s are 28, leaves you with a 1. 7 2s are 14, not divisible. 998, 997 will not be divisible. 996, let's look at this. 7 1s are 7, leaves you with a 2. 7 4s are 28, again not divisible. 995, 7 1s are 7, 7 4s are 28, leaves you with a 1. 994, this will be divisible. Okay, so 7 1s are 7, leaves you with a 2. 7 4s are 28, leaves you with a 1. 7 2s are 14. So the last 3-digit number, so this is basically the first 3-digit number. This is the first 3-digit number divisible. This is the first 3-digit number divisible by 7, and this is the last 3-digit number. This is the last 3-digit number divisible by 7. This is the last 3-digit number divisible by 7. So if we happen to make a series, so all 3-digit numbers, all 3-digit numbers divisible by 7. They will form all 3-digit numbers divisible by 7. What will they be? First one will be, obviously, the first number will be 105. What will be the next number? It will be 112, then 190, and so on and so forth till 994. So this is basically forming an AP. This is an AP with first term A is equal to 105, with common difference D is equal to 7, and with the last term AN is equal to 994. What you have to find out is the number of numbers that we have. Okay, we have to find out basically the value of n. So let's put it here. AN we can write A plus n minus 1 into D. This is equal to 994. So in place of A we put it as 105. N we are not aware, so we leave it the way it is, into D. D here is 7 is equal to 994. So n minus 1 into 7 is equal to 994 minus 105. That leaves you with how much? 9 plus 5, 14, 8. So this will be 989. 989. Are we getting this correct? 7 1s are 7, 7 4s are 28, 7 2s are 14. Okay, 989. So n minus 1 will be equal to 989 by 7. So this will be 7 1s are 7, leaves you, something is going wrong here. This will be 889. This will become 889. 889. Okay, so 889 by 7. So this will be 889 by 7. 7 1s are 7, leaves you with 1. 7 2s are 14. 7 7s are 49. N minus 1 is equal to 127. So therefore n is equal to 127 plus 1. That is 128. N will have a value of 128. So how many 3-digit numbers are divisible by 7? There 128 3-digit numbers. 128 3-digit numbers are divisible by 7. Okay, 128. So that basically solves the problem. Okay. So if you look into this, we have found out which is the first 3-digit number. So what is the first 3-digit number? The first 3-digit number here, the first 3-digit number here happens to be 105, and the last 3-digit number, again moving on, we locate that the last 3-digit number is 994. Okay, so in this way we are going to solve the problem and get the value as 128. So there are 128 3-digit numbers which are divisible by 7. How many multiples of 4 lie between 10 and 250? So how many multiples of 4 are lying between 10 and 250? That is something that we have to basically find out. Let's look at this. Okay, let's look at this. How many multiples of 4 lie between 10 and 250? Okay, so let's bring this up here. So after 10 it is 11, then we have 12. So the first thing is, the first multiple is 12, and 250 we know is not divisible by 4. Is 249 divisible? Certainly not. Is 248 divisible? Yes it is. Okay, yes it is. So the last number will be 248. So with this we will get an AP. Okay, with this we will get an AP. The AP is basically what? AP is starting from 12. Obviously the next number will be 16, then 20, and so on and so forth till 248. So here this is an AP with A is equal to 12 and common difference D is equal to 4. Obviously the last term here, that is AN, is 248. The last term here is 248. So let's look at this. How many? So what you have to find out is basically the value of n. What we have to find out is the value of n. So how do we find this out? So here we will do an AN is equal to A plus n minus 1 into D. So AN here is how much? 248 is equal to A, that is 12, plus n minus 1 into D, which is how much? 4. So if I happen to take this here, so this will be 248 minus 12 is equal to n minus 1 into 4. So that's 8 minus 2, that is 6, 4 minus 1, that is 3, 236 is equal to n minus 1 into 4. So n minus 1, 236 by 4, 4 5s are 20, 4 9s are 36, that is n minus 1. So n will be equal to 59 plus 1. So therefore n is equal to 60. N will have a value of 60. So how many multiples are there between 10 and so that we can say that there are 60 multiples. There are 60 multiples between 10 and 250. So there are 60 multiples between 10 and 250. Okay, that's how we will proceed here. Okay. So this is basically 60 multiples between 10 and 250. Find the 20th term from the last term. Now this is basically a tricky question. You have to find out the 20th term from the last term. Okay, so let's say we will first evaluate the AP here. So the AP here is 20th term from the last term of the AP. So 20th term from the last term. So here we have the AP as AP is 3, 8, 13 and so on and so forth till 253. So obviously A here is how much? 3, D is 5 and AN is 253. AN is 253. Okay. So A here is 3, D is 5 and AN is 253. Now we have to find out the 20th term from the last term. So we can write this AP as this, or what will be the reverse AP? What will be the reverse AP? If we write in the reverse format. So this will be 253. What is the number just ahead of it? Obviously we know that it is minus 5. So here it will be 248. Here it will be 243 and so on and so forth. We will come down to 13, 8 and finally 3. So this will be the reverse AP. If we notice here, the first term A is 253 and the common difference D is minus 5. Here the first term A is 253 and the common difference D is minus 5. Okay. So how do we calculate this? Now we have to basically calculate the 20th term of this AP. 20th term of this AP. So this will be A20 will be equal to A plus 20 minus 1 into D. So this will be A, that is 253 plus 20 minus 1, that is 19. Again D here will be minus 5. Okay. So this will be 253 minus 9 5s are 45, 5 1s are 5 plus 4 9. So this is going to be 253 minus 95. So that's going to be 156. Okay, that's going to be 156. So therefore 156 is the answer. This will be the answer. Okay, let's look at the solution here. Let's look at the solution here. So if we do a reverse, 20th term, 158. We have missed out on something. Then 158, is it? Yes, sorry, this will be 8. I am so sorry. This will be 158. Yes, so this will be 158. If I subtract this, this will be 158. So the 20th term, so we can say this is basically the 20th term from the end. 20th term from the end is 158. Okay, let's move ahead, people. The sum of the 4th and the 8th terms of an AP is 24 and the sum of the 6th and the 10th term is 44. Find the first 3 terms of the AP. So let's look at it. Let's look at it here. sum of the fourth and the eighth terms of an AP. So let's say here we have, again we are not aware of what is the first term and what is the common difference. So let A be the first term and D be the common difference. Let A be the first term and D be the common difference. So what is the fourth term? A plus 3D. And what is the eighth term? A plus 7D. The sum of the fourth and the eighth terms of an AP. So the sum of the fourth and the eighth terms of an AP is 24. A plus 3D plus A plus 7D, that's equal to 24. So this will be 2A plus 10D is equal to 24. If I happen to divide this by a 2, this will give me A plus 5D is equal to 12. A plus 5D is equal to 12. This becomes my first equation. This becomes my first equation. Okay. The sum of the sixth and the 10th terms. So let's say sum of the sixth and the 10th terms. So T6 is equal to A plus 5D and 10th term will be equal to A plus 9D. So T6 plus T10, that is equal to how much? 44. So T6 is how much? A plus 5D plus A plus 9D, this is equal to 44. So A plus A, that is 2A plus 9 plus 5, that is 14D is equal to 44. If I happen to divide this by 2, I get what? A plus 7D is equal to 22. So that is basically second. Okay, that is basically second. So this is second. Okay, now find the first three terms. So if I do a subtraction here, subtracting 1 from 2. So what do I get? A plus 7D is equal to 22 and A plus 5D, that's equal to 12. If I happen to subtract this, this is minus, this is minus and this is minus. This gets cancelled. This is how much? 2D is equal to 0 and 1. So therefore D is equal to 10 by 2, that is 5. So D will be equal to 5. Okay. Now substituting, we have already found the value of D. So substituting in equation 1, what do we get? A plus 5D is equal to 12. A plus 5D is equal to 12. So here we have A plus 5 into 5 is equal to 12. So that will be A plus 25 is equal to 12. So this will be A is equal to 12 minus 25, that is minus 13. Okay, you have to find the first three terms of the AP. So now we know that the value of A here is minus 13 and the value of D is 5. So the AP will be, so the first term will be minus 13 plus 5, that will give you minus 8 plus 5, that will give you minus 3. So these are the first three terms of the AP. Okay. All right, people. Let's look at what is the solution provided here, just to reconfirm whether we have arrived at the proper. So this is going to be five, and what we get A as minus 13. So obviously the AP will be minus 13, minus 8, and finally minus 3. Okay. Two APs have the same common difference. Okay. The difference between their 100th term is 100. What is the difference between their 1000th term? Okay. So there are two APs. They have the same common difference. So let first AP. So obviously let's say we say A1 be the first term. Let A1 be the first term of the first AP. Let A1 be the first term of the first AP, and let A2 be the first term of the second AP. Okay. We know, let D be the common difference of both the APs. Let B be the common difference of both the APs. Okay. So here we have 100 term. So the first AP, so this will be a 100th term. A 100 is equal to a plus 100 minus 1 into d. So this will be a plus a 100 is equal to a plus 99d. So this will be a1 plus 99d. This becomes your 100th term. Okay, now for the 1000th term, the difference between the 100 term is 100. Now let's say for the second AP, let's say a dash, we keep it as a dash 100 term will be again a2 plus 100 minus 1 into d. So what will be the value of a dash 100? This will be equal to a2 plus 99d, a2 plus 99d. So this gives your a2 plus 99d. So here the difference between the two terms, the difference here it is given as, what is the difference? The two APs have the same common difference between their 100th terms is 100. So this is the 100th term of the first AP, this is the 100th term of the second AP. The difference between these two is how much? 100. So if I do this, a dash 100 minus a 100, this will be equal to a2 plus 99d minus a1 plus 99d. So this gives you a2 plus 99d minus a1 minus 99d. This gets cancelled, so it leaves you with a2 minus a1, and this has a value of 100. So we know that the value of a2 minus a1 is equal to 100. Okay, what is the difference between their 1000 term? So therefore difference between their 1000th term, obviously what will be the difference? A1 plus, so 1000th term of this AP will be how much? A1000 will be equal to a1 plus 999d. And what will be the 1000th term of this? This will be a dash, let's say 1000th term, that will be a2 plus 999d. If I happen to do a dash 1000 minus a 1000, what do I get? Obviously a2 minus a1, and 99d minus 99d. So a2 minus a1 we know is 100. a2 minus a1 is known as 100. So whatever, no matter which term you take, whether you take the 10th term, 11th term, 1000th term, 10,000th term, the difference between the two APs will always be the difference between A2 and A1, which will be basically their first terms. And the first term difference we know is 100. So this is going to be more or less a constant answer till the time we are taking the same terms in both the APs. Till the time we are trying to find out the difference of the same terms in both the APs. Okay, all right. So let's look at this. So again, if we look at it, we have 100. So this will also be 100. This will also be obviously 100. Difference between their 1000th term is also 100. Difference between their 1000th term is also 100. Okay, that basically comes.